Welcome Pinksters. Today let us learn about simple linear regression. So what exactly is regression? Regression is a supervised learning technique that establishes the relationship between a dependent variable and an independent variable. Now before we proceed further, let us understand what exactly is supervised learning. In simple terms, supervised learning is a machine learning technique that is based on supervision. That is, just like a student who learns under the supervision of a teacher. Therefore, in supervised learning, a sample labeled data is fed to the machine learning model to train it. Based on this labeled data, it predicts the final outcome. Therefore, supervised learning allows us to create a model using labeled data that reads the data sets and learns each feature of the data set. After training and processing are complete, then the model is tested with the help of a sample data to check its efficiency of predicting the output on future data. Thus, the goal of supervised learning is to map input data to the output data. Now, if this was confusing, let us have a look at a simple example which will make things quite clear. Suppose we have a data set of different types of shapes which includes a square, a rectangle and a circle. Now the first step is to train the model for each shape based on its labels. So this means if the given shape has 4 sides and all the sides are unequal, then it will be labeled as a rectangle. If the given shape has 3 sides, then it will be labeled as a triangle. And if the given shape is round with no corners, then it will be labeled as a circle. Now after the training, we test our model. This is done using a test set, and the task of the model is to identify the shape. The machine is already trained on all types of shapes, so when it finds a new shape, it classifies the shape on the basis of the labels and predicts the output. As you can see in this case, in our test data, we are feeding a rectangle and circle into our model. Since our model already knows that these are a rectangle and a circle based on the training it received previously, therefore it easily predicts that this is a rectangle and a circle. So this is how supervised learning works. Now supervised learning can further be divided into two types. These are classification and regression. And regression is what we are going to learn now. And regression can further be divided into numerous types. So what we are going to learn is simple linear regression. So what is simple linear regression? Simple linear regression is a type of regression algorithm that models the relationship between a dependent variable and a single independent variable. Now please note that I am emphasizing on the term single independent variable. This is because if we have more than a single variable, then it would no longer be a simple linear regression. In that case, it becomes an algorithm like a multiple linear regression. Do not worry, we will be discussing them in due course of time. As of now, please focus on simple linear regression. Now the next question is, why is it known as linear regression? Now it's quite simple. The reason is the relationship shown by a simple linear regression model is linear or a sloped straight line. Hence it is called simple linear regression. So that means if you plot a graph between the dependent and the independent variable, then you will get a straight line. Now please have a look. Do you remember this equation? Many of you might have come across this equation in your high school. This is the equation of a sloped straight line. Y denotes the variable that needs to be predicted. Hence, it is our dependent variable. The value of y is dependent on the value of x. Thus, x is the input or the independent variable. M denotes the slope. In mathematics, the slope of a line is a number that describes both the direction and the steepness of the line. In simple words, the steepness, incline, or the gradient of a line is measured by the absolute value of the slope. C denotes the y-intercept. You can visualize it as the constant that determines what shall be the value of y when x is 0. So now let's have a look at an example of the equation of a straight line. Now this straight line represents the equation y equals 2x plus 1, such that y is our dependent variable and x determines the value of y. That's why it is our independent variable. Now 1 is the intercept. This means when the value of x is 0, the value of y will be 1. Now what's 2? 2 is the slope. So if you look closely, you'll find that for every change in x, y will change by 2 units. Now let's try and understand this. When the value of x is 1, the value of y is 3 based on this equation. How come? 2 into 1 plus 1, that's 3. Now, when the value of x changes to 2, y simultaneously changes to 5. And how did that happen? That happened because 2 into 2 plus 1, that means 5. And as you can see, y changed by 2 units. So I hope this was clear. Now if this is clear to you, then the concept of simple linear regression will become quite easy. This is because simple linear regression is nothing but a manifestation of this equation or the equation of a straight line. Now you know, in real world things are not always as simple as you can see on the screen. The points that you can see on the line are not always like this. They are often scattered when it comes to real world scenarios. So that's where simple linear regression comes into the picture. Now let us quickly go through the formula for simple linear regression, and then we shall understand it in depth with the help of an example so that we can visualize things and things become quite easy for us. So this right here is the formula for simple linear regression. Here x is the independent variable, y is our dependent variable, beta 0 represents the intercept of the regression line, while beta 1 represents the slope of the regression line, and epsilon represents the error term. By now it is quite clear to you why I explained the equation for a straight line. This is because if you compare the two equations, then you will find that this is quite similar to that. And in fact, it is actually an implementation of the same equation itself. However, you might be thinking, what is the error term? Or why do we even need the error term? Now this is because linear regression models are not always perfect. It approximates the relationship between dependent and independent variables, and the approximation often leads to errors. Some of these errors can be decreased, while some errors are inherent to the problem and cannot be eliminated. Such errors which cannot be eliminated are known as irreducible errors. Now this was all about the formula. Let us try and understand an implementation of this formula with the help of an example. Now this right here on the screen is a scatter plot. As I mentioned earlier, real-world scenarios are not always as simple that all the points will lie on the same line itself. These points can be scattered. So as you can see in this diagram, that the points in the graph are scattered. Now what's this graph is all about? This is a graph representing the salary with respect to the experience of a person. For example, when the experience of a person is 0, we find that his salary is 20k. When his experience is around 1 year, his salary is found to be around 30k. Now the salary depends on numerous factors. So as you can see that the values of the salary have not necessarily followed an increasing trend, or it has not even followed a decreasing trend. Yet we can draw a line through these points. Now what is this line, or how do we even draw this line? So this line is known as the best fit line. This is the line which will help our model to predict the output based on a given experience. So the best fit line is a line through the scatter plot of data points that best expresses the relationship between the points. In other words, you can think of this line as the line that best approximates or which best estimates the value of these points. Now if we try to map this scatter plot to our simple linear regression formula, then it will look something like this, wherein the salary, which is the dependent variable, is dependent on the independent variable experience, and beta 1 is the slope, while beta 0 is the constant or the intercept. So this means when the experience is 0, then the salary will be determined by beta 0, which is the constant term, and in this case it is going to be 20. Now it is quite difficult to find a perfect approximation for the best fit line. However, there is an algorithm which helps our regression model to find the best fit line, which is quite effective in predicting the output or the salary based on the experience. However, to understand that, we must understand the mathematics behind simple linear regression, or the method that is used by our regression model to compute these results. Therefore, we will learn the complete mathematics used by our model behind this concept in the next video, where I'll be explaining you how we can deduce, or how our model can deduce this formula, and then we shall also learn about the algorithm used to find the best fit line. That was it for this lecture. Please join me in the next lecture, where we shall be learning how the maths behind simple linear regression works.